Ant colonies in the field will often have access to multiple sources of food. Those resources will have different qualities. Some might have a lot of nutritional value, and others might not be as rewarding. The food sources will probably also be different distances from the nest. Some will be close and others farther away. This introduces a trade-off between quality and distance that the colony has to navigate. It takes more energy to travel large distances, as well as to maintain pheromone on the trails. So when is it worth it to construct trails to far away high-quality resources? We've used a differential equation model to gain insight into how the use of pheromone influences a colony's treatment of this trade-off. The info for the paper where we introduce this model is below as well as on the poster. This model is a system of equations describing the rate of change of the number of ants on a trail to a resource. There's one equation per food source. Each equation has 5 main terms. The first 3 describe the rate that the ants are joining the trail. The rate of ants randomly searching and finding resources is added to the rate of ants being recruited to the trail, or joining it from the nest. That sum of rates is then multiplied by the number of available ants who aren't committed to foraging at a particular resource. The last 2 terms describe the rate of ants leaving the trail. The ants might leave because the pheromone is evaporating or because they've wandered off and lost track of the trail they were following. We're interested in the way that parameters representing how ants use pheromones can influence the types of resources they forage at. Here are 2 graphs of the average quality on the y-axis and distance on the x-axis of the top 2 resources ants foraged at. The averages are weighted by the number of ants on the trails. So, the most visited resource has the most influence over the average quality and distance. Each point represents one numerical simulation of the DE model. Each of the graphs contain 5,000 runs. The qualities and distances of resources were drawn from uniform distributions are identical in the 2 graphs. So the only difference between these 2 graphs are a few parameter values. The blue graph has a high rate of ants joining the trail, and the orange graph has a low rate of ants leaving the trail. Something to notice is that in the blue graph, colonies are willing to forage at resources that are very far from the nest, provided they are higher quality. However, in the orange graph, colonies seem to focus their foraging efforts on nearby resources, even if they aren't high quality. In this model, different ways of using pheromone influence the way that colonies dealt with far-away, high-quality resources. For more details on how, come see the poster. In the future, we hope to parameterize the model to reflect the different ways particular species use pheromones. This could yield insight into how different species balance this quality-distance trade-off when foraging.